It uniquely identifies your device on a network. And the location addressing means it helps a data packet find a way to correct the device. So there are two major versions of IP in use today, that is of IPv4 and IPv6. So in this video we are going to focusing on IPv4, which is still the most widely used. So what is IPv4? So IPv4, it stands for Internet Protocol version 4. It was introduced in 1983 as part of the ARPANET project, so which was the foundation of the modern internet. So IPv4 uses a 32-bit address system, meaning it can generate approximately 4.3 billion unique addresses. So an IP addresses looks like 192.168.0.1. That is of it consists of 4 numbers that we called as octets. That octets separated by dots. You know well about that IP address. So each octet can have a value between 0 and 255. So even though 4.3 billion sounds like a lot, the rise of the internet or smartphones and IoT devices has caused us to the run out of IPv4 addresses, which is why IPv6 was introduced, but we will get to that later. So how IPv4 works? The IPv4 addresses are written in decimal form, but computers process them in binary. Each addresses consists of 4 groups of 8 binary numbers. Let's take an example of IPv4 addresses is 185.107.80.231. What is the binary equivalent for 185? That is of 10111001. We have to calculate the for every numbers which was separated by dots. So in binary, we have to understand that the system only understand that binary values, like if we have 185 means the computer or system will understand is 10111001 point like this. This format helps computer effectively process the IP address. Okay. Then we have to see about the parts of an IPv4 address. So an IPv4 address is divided into 3 main parts. First one is network part, host part, and subnet number. What is the role of the network part here is it identifies the network to device it belongs to, and the host part is it uniquely identifies the specific device within that network. What is the role for the subnet number is it further divides larger network into smaller subnetwork for better management. For example, we have seen an IP address like 192.168.1.10. What is the role here is 192.168.1 is the network part. The last 10 is the host part, which represents a specific device. This structure allows efficient routing of data across the networks. Next, the topic is types of IPv4 addressing modes. There are 3 main types of addressing modes is of unicast, broadcast, and multicast. Unicast means it's a one-to-one communication. Broadcast is one-to-all communications. Multicast is one-to-many communication. Additionally, there is anycast that is of use in IPv6, but conceptually it is similar, where data is sent to the nearest node in a group. What is the briefly you can see about the 3 addressing modes. First one is unicast communications. In unicast, data is sent from one sender to one receiver. Think of it like sending a WhatsApp message to your friend, only they receive it. This is the most common form of communication used when we browse the websites or sending the emails or download the files. Let me see the real world example is of imagine you are ordering the food on app. The restaurant receives your request only. This is a unicast. Technically, the web browsing relies on unicast. When you visit a website, your request is sent to the server and the server responds to you specifically. What is the meaning for the broadcast communications? In broadcast, data is sent from one sender to all devices in a network. It's like announcing something on a loudspeaker, that is of everyone have to hear it. Used in network discovery protocols and DHCP, that is of dynamic host configuration protocols. Imagine that when your office IT team sends a message that Wi-Fi maintenance is happening, everyone on the network gets the messages of that is broadcast. Technically, broadcast is used in ARP, that is of Address Resolution Protocol, to find the MAC address of a device within a local network. Then let me see the multicast communications. Multicast is used for one-to-many communications. Instead of receiving everyone, it reaches only a selected group. So common in a live video streaming, online gaming and conferencing, it is based on the multicast communications. Let me see, imagine that a live sports broadcast on a streaming service. It sends to multiple subscribers but not everyone on the internet. For technically, what we have to see that is a multicast is used for video conference tools like Zoom and WebEx, where a speaker communication with many listeners without overwhelming the network traffic. What is the next? That is of anycast communications. Already we have discussed of anycast communications previously. That is, anycast is a special type of addressing mode that is seen in IPv6 but conceptually present in some IPv4 networks. It routes the data to the nearest or the most efficient receivers in a group. It's commonly used in content delivery networks, that is of CDNs and DNS servers, domain naming system servers. Let me imagine that when you open a website like Google, your request is routed to the nearest Google server, that ensuring the fastest response times, that is of any cast in action. Technically means it's a DNS server is used any cast to ensure fast website access. The nearest DNS server responds to your request instead of overwhelming a single server. Okay. Let me see. Subnetting is the process of dividing a large network into the smaller manageable subnetwork. This helps effectively allocate the IP address and improve the security. What are the key concepts that are used in there is subnet mask, CIDR notation, subnet calculations. That is, determines how many bits are allocated for the network and the host. For example, that is of 192.168.1.0, that is, it means that 24 bits are of the network. It helps to reduce the IP wastage in large organizations. And what are the advantages of IPv4 is it's a simple and widely adopted, that is of most devices supported it, and effectively routing and communication, that is of we can able to optimize for network. It's compatible with older devices. It also works well with existing technology. It supports a BLSM, that is of variable length subnet masking, that is it allows a flexible subnetting, and well established security protocols, that is of firewalls and VPNs are built around the IPv4. What are the challenges faced in IPv4 is limited address space, that is of IPv4 is running out of unique address, and the security addresses, that is IPv4 is vulnerable to hacking, spoofing and DDoS attacks. Complex network management, it requires a NAT, that is of network added translations, and lack of built-in authentication, that is IPv4 does not have built-in encryptions. Okay, let's see the challenges. What are the solutions we have to find in the security used in IPv4? That is of firewall. That is, with the use of firewall, we can able to protect the network by filtering the traffic. And VPNs, that is of virtual private network, it securely encrypted the data. And IPsec, that is of internet protocol security, it's add the authentications and encryptions. And MAC filtering is of restricts access to specific devices. Okay, let me see. What are the features of the IPv4? Even though IPv6 is the future, IPv4 is still in use. Here's what is to expect is gradual transition of IPv6. That many computers are shifting, but IPv4 will coexist for years. It continued use of NAT. Large scale networks will continue the using NAT to conserve the IPv4 addresses. And security enhancements. It's more robust firewalls and VPN solutions will emerge to address the IPv4 vulnerabilities. Okay. What IPv4 is and address of addressing modes and the unicast, broad, multicast, subnetworking, security challenges, and if you found is this helpful, hit the like button and subscribe for more networking tutorials. And if you have any questions, drop them in comments. Thank you for watching and I will see you in the next video. Happy learning.